What do you wonder about?
The unknown.
What our place in the universe is?
Artificial intelligence.
Hello.
Look at this. What's this?
Animals.
An egg.
Your brain.
Life on a faraway planet.
Nova Wonders, investigating the biggest mysteries.
We have no idea what's going on there.
These planets in the middle, we think are in the habitable zone.
And making incredible discoveries.
Trying to understand their behavior, their life, everything that goes on here.
Building an artificial intelligence is going to be the crowning achievement of humanity.
We're three scientists exploring the frontiers of human knowledge.
I'm a neuroscientist, and I study the biology of memory.
I'm a computer scientist, and I build technology that can read human emotions.
And I'm a mathematician using big data to understand our modern world. And we're tackling the biggest questions
Dark energy.
Dark energy.
of life
There's all of these microbes, and we just don't know what they are.
and the cosmos. On this episode, the hunt for alien life is on, turning up mysterious clues.
The star loves attention, and it makes everybody crazy.
That's not a planet. So what is it?
What are the odds?
The ingredients for life are everywhere.
The universe has hundreds of billions of planets.
But does anything live there?
The chances of us finding life is very high.
Nova Wonders. Are we alone? Right now. The planet Earth. A ball of rock about 8,000 miles in diameter. We know there's a lot going on here.
Almost 8 billion people call it home, along with billions of other species.
But is this the only place where the action is?
Our sun is just one of an estimated 300 billion stars in the Milky Way.
And we think there are at least 100 billion other galaxies.
So what are the chances that all the fun is only happening right here in our tiny corner of the universe?
Today, astronomers and engineers are building new tools to probe our solar system and our galaxy, hunting for clues of life beyond Earth.
What are they discovering?
I'm Rana El-Khalyoubi.
I'm Andre Fenton.
I'm Talithia Williams, and in this episode, Nova Wonders. Are we alone? And what will it take to find out? A few years ago, a group of amateur astronomers discovered a mysterious star. Located about 1,500 light years from Earth, the star flickers erratically, and no one knows why. If the star dims at regular intervals, chances are it's caused by an orbiting planet, and typically it's only by a fraction of 1%. But the light from this star is dimming by more, much more.
The thing about this star is the light dims every now and again, but it's being dimmed by 22%. So that's not a planet. That's much too much. Even for a Jupiter-sized planet, you don't get anywhere near that kind of dimming. So what is it? Unlocking the star's secrets becomes the quest of Tabitha Boyajian, a stellar astrophysicist. Soon, people are calling it Tabbys Star.
We worked with dozens of other astronomers for several years trying to figure out what could be causing these strange fluctuations in its light.
Is it caused by an asteroid belt? Or colliding planets?
So we had this whole long list of ideas. None of them worked.
Then one of Tabby's colleagues offers a possible idea, a bit outside the standard astronomy box.
When I showed him this star, he said, "Wow, this is really weird, and we don't have an explanation for it." He said, "These things all look like they could be caused by some artificial alien megastructure."
An artificial alien megastructure. A giant structure built by a hypothetical alien civilization to harness the energy from its own sun. when the word gets out,
Talk about the prospects of an alien megastructure.
Evidence of alien life.
The strange light pattern makes it seem more like a Death Star planet rather than a star.
The star loves attention. And it makes everybody crazy.
it is far-fetched. To dim a star by so much, an alien megastructure would have to be at least half as big as the star itself. But when the theory is first proposed, astronomers can't rule it out.
The behavior of Tabbys Star is quite weird.
Given that we have no idea what's going on there, I'm not too quick to throw out theories.
Could this be some alien megastructure? We don't know.
Tabby and her team will continue to study the star, hoping to find more evidence.
For some people, the idea that there's a civilization out there capable of building a giant structure around its sun would be a dream come true. It's the same dream that fuels our obsession with aliens.
Whether they charm us,
I am Groot,
frighten us, seduce us,
oh no,
or try to kill Tom Cruise. And it's not just the movies. Even the Pentagon recently admitted that it secretly investigated UFO sightings for years.
But what's the reality? Right now, as far as technologically advanced life goes, we have a sample size of 1. Us. In fact, when it comes to any form of life, whether it looks like this, or this, or this, the only examples we know of are right here on Earth. And the truth is, if we found even one other example of this kind of life, it would be the biggest scientific discovery in our lifetimes.
So where do we start to look? In 2009, NASA took a major step in the hunt for life beyond Earth, launching the Kepler Space Telescope to track down signs of Earth-like planets beyond our solar system. Up until then, astronomers had found about 300 exoplanets, but few were anything like Earth. Small, rocky planets like ours are not easy to spot.
Planets are literally lost in the glare of their parent stars. The brightness difference, the contrast between a star like our sun and the Earth that's right next to it is 10 billion to 1.
So instead of hunting for light reflecting off a planet's surface, the telescope focuses on starlight.
What Kepler did was look in a part of the Milky Way galaxy where we had lots of stars in a small field, and it just took pictures over and over again. And occasionally, if those stars have planets, then sometimes those planets would come in front of the star.
As the planet comes around, it's going to block part of the star, and that light won't get to you. And so that constant level that you see from the star suddenly goes down just a bit.
So these momentary dimmings of light that repeat once every orbit are indicative of a planet orbiting a star.
Astrophysicists like John Asher Johnson and his team at Harvard use Kepler data to estimate an orbiting planet's size and distance from its star.
The dips are pretty deep, so it must be a fairly large planet.
Deep dips in the star's light mean the planet is really big, or the star is really small.
The spacing between this, what is that, like a day or two?
And frequent dimming means gravity has drawn it close to the star, making the planet really hot.
It's pretty much like a classic hot Jupiter.
A giant broiling ball of gas like this would not be a great spot for life. So the team looks for signals that are more subtle.
Looking at this, it doesn't look like much, but it looks like there is some kind of periodic signal there.
So what do we know? We know this thing is small?
It's blocking out less than 1% of the light that we're receiving.
Something is causing the star to dim ever so slightly and at longer intervals. Could this be a small planet, closer to Earth size? And the distance from his sun suggests temperatures potentially comfortable for life.
This is really interesting. I mean, this is exactly the kind of thing that we're looking for. This could be a rocky planet somewhere near the habitable zone.
Yeah, this is really exciting.
Yeah.
The discoveries coming from Kepler have been astounding. Nearly 3,000 confirmed planets so far.
The Kepler Space Telescope blew open our understanding of planets.
We have found lava worlds. We've got planets that are orbiting not one, but 2 stars. We have found planets that may be covered entirely in liquid water.
And some of these planets are Earth-sized, with temperatures potentially ripe for life.
Kepler allowed us to see the sheer numbers and the absolute commonness of Earth-sized planets throughout the galaxy. And so the chances of us finding life elsewhere, in my view, is very high.
In fact, using the small sample of sky observed by Kepler, astronomers now estimate that there are tens of billions of planets in our galaxy, the same size and temperature as Earth. These planets could have liquid water on their surfaces. Their rocky cores could hold the building blocks of life. And their stars should provide plenty of energy.
But does that mean that life would thrive there? Turns out, that could depend a lot on the star itself.
Planets are really at the mercy of what happens to the stars that they're orbiting around.
Dad, can you walk slower, maybe?
Jason Callery is a stellar astrophysicist.
What are you guys excited about seeing today?
I'm excited about seeing Saturn.
Saturn should look amazing.
An expert in the behavior of stars, he knows the profound influence they can have on orbiting planets.
So by studying those stars, we can figure out what kind of planets might be most suitable for finding life. All right, so here's our main mirror. Do you guys remember what this is called?
The first mirror?
Primary mirror.
Oh, primary.
Jason's curiosity about the cosmos started early.
As a young kid, one of the things that I found most exciting was trying to figure out how the universe works. And countless times I would be in our backyard looking up at the night sky, wondering what part of the universe I'm seeing.
Jason had clear views of the sky in British Columbia, where he grew up. His parents moved there from Punjab, India, in the 1970s.
If they had stayed in India, I would not be an astronomer. That's just the way the system is. But in Canada, I could take a liking to whatever I liked. And as a very young kid, I liked astronomy. And when I wanted to become an astronomer and see that through, there was nothing stopping me.
Today, he shares his love of astronomy with his twin daughters, Soraya and Mira.
Are there any people on different planets?
So there's lots of stars in the universe. And so all of those stars have planets around them. So on one of those planets right now, there might be a dad with his 2 daughters on a farm looking up at the night sky asking the same question.
OMG.
I love showing my daughters the night sky through a telescope.
Is that Saturn?
Because
Whoa.
you see so much more out there that's otherwise invisible to us. Is that cool?
Yeah.
That instills that curiosity to want to go and find out those answers. And with astronomy, they'll never be satisfied because it'll always just throw more questions at you.
Jason pursues his questions about the cosmos at the Space Telescope Science Institute in Maryland. And when it comes to the search for alien worlds, he focuses on the kinds of stars that might be friendliest for life. Because not all stars are created equal.
When we look up at the night sky, we're seeing just the brightest beacons of light. It's not representative of the true distribution of stars, which contains many more lower mass stars, stars much smaller than the sun.
These low-mass stars, sometimes called red dwarfs, are smaller and cooler than our sun. And while our own sun will burn out in about 5 billion years, red dwarfs could burn for trillions of years. Across the Milky Way galaxy, red dwarfs probably host billions of planets, many of them small and rocky, like Earth. So how likely is it these planets host life? One group of planets just 40 light years away has enticed scientists like Jason. The TRAPPIST-1 system.
One of the biggest discoveries in the last few years was the discovery of the TRAPPIST-1 system. This is an incredible star.
TRAPPIST-1's 7 planets are all close to Earth size and circle it in tight orbits, like a condensed version of our own solar system.
These planets take a few days to go around their star, and they're only located a couple million miles from their star.
TRAPPIST-1's innermost planet orbits its host star every 1.5 days.
It's 90 times closer to the TRAPPIST-1 star than our Earth is to the sun, and so it's going to be very hot on that planet.
Though not a lava world, it's too hot for liquid water or for life as we know it.
The other end of the extreme, we've got planet H, which is going to take about 20 days going around the TRAPPIST-1 system, which is a huge amount of time given how faint the TRAPPIST-1 star is. And so it's going to be very cold.
Any water here is likely frozen solid. But a few TRAPPIST-1 planets seem to orbit in the Goldilocks zone, just right, with temperatures that could be similar to those on Earth.
We think these planets in the middle are in the habitable zone. Conditions are going to be just right where liquid water could exist.
When the discovery was first announced, hopes were high that some of these planets might harbor life. But Jason is more skeptical, not because of the planets, but because of this star. Red dwarfs may be small and cool, but they are also more violent and volatile than our sun.
These are generally pretty active stars. These exhibit a number of solar flares where there's material that can impact the planets.
This material carries enormous amounts of radiation, many billions of hydrogen bombs worth, enough to destroy the cells of any living thing on a nearby planet. Jason fears these radioactive solar flares could wipe out any life that might arise in the TRAPPIST-1 system.
It's actually unclear whether or not the conditions necessary to sustain life and the time that life needs to develop are going to be stable on these planets.
Jason isn't giving up on planets that orbit red dwarfs, but he does worry that life there may be so different from our own, we might never recognize it.
I have no doubt that planets that are very different from Earth and stars that are very different from the sun will still lead to different types of life. But we don't know what we're looking for. So the simplest experiment is to try and find life that resembles the life that we understand well on Earth.
So can we find a twin? An Earth-like planet orbiting a sun-like star? Kepler tracked down a few, but they're more than 1,000 light years away. How can we find more and closer? Luckily, a new detective is joining the hunt. NASA's Transiting Exoplanet Survey Satellite, called TESS.
TESS will now do a survey of all the nearby stars so that we can find the very closest planetary systems to us.
The telescope's 4 cameras will observe some 200,000 stars, many big and bright like our sun.
TESS will take a snapshot and it will image all the stars along the strip of the sky, and then it'll move on and do the next set of stars and the next set of stars. That's when there's going to be this fire hose that's going to turn on. All of a sudden, we're going to get data from all the closest stars.
Data that could translate into thousands of nearby planets, including a lot like our own. We could soon find ourselves surrounded by potentially habitable neighbors. But then what? If we find a nearby twin, could we ever know if life exists there?
The very closest potentially habitable planets are a few light years away. That's about 25 trillion miles. Even if we built a spacecraft that could travel 1 million miles an hour, it would take about 3,000 years to get there. But even if we can't go there, it might be possible to find evidence of life on a faraway planet, in effect, by sniffing its atmosphere.
mean, we'd all love to find an alien. We'll just be lucky to find anything at all. So at this point, it doesn't matter what it is. We just want to find some sign of life.
MIT astronomer Sarah Seeger thinks that sign will come in the form of gases in a planet's atmosphere called biosignatures.
We call a gas a biosignature gas if it's a gas that's produced by life that accumulates in the planet atmosphere.
About 2.5 billion years ago, life on Earth began pumping out a powerful biosignature. Colonies of bacteria, like these stromatolites, started producing oxygen, like plants do today. Now, our atmosphere is roughly 20% oxygen, a telltale sign of life. But how could we ever study a distant planet's atmosphere and detect what gases it holds?
If the planet and star are fortuitously aligned, that starlight can shine through the planet atmosphere.
Different gases will absorb starlight in different ways.
It turns out that each gas has its own specific way of interacting with light.
We're all familiar with glowing colored gases. They're what light up the neon signs of cities.
In this tube, for example, there's mercury showing up as a blue. I can change that out for another gas. This one is helium. It looks orange.
When Sarah splits the light, she can see even more detail. Each gas has a unique light signature. These signatures could tell Sarah about the gases in a planet's atmosphere. Gases that could be signs of life. But to see them, she'll need a very powerful telescope. In 2020, NASA plans to launch the James Webb Space Telescope, the most powerful space-borne telescope to date.
The James Webb Space Telescope has a 21-foot gold mirror, so it can make exquisitely sensitive measurements of the atmospheric composition of other planets.
It makes those measurements with the help of a device called a spectrometer, which, like a prism, divides light into constituent colors. This helps scientists like Sarah identify gases surrounding a planet.
We hope to see gases like water vapor on a small rocky planet, which would indicate liquid water oceans. We'd like to see methane and other gases, and some of these on their own or together would help make the case for life on another planet.
But even with those gases, the case might be missing a crucial piece of evidence.
Those are pieces of the puzzle, but that puzzle will be incomplete until we detect oxygen.
Astrophysicist Mercedes Lopez Morales wants to find oxygen in another planet's atmosphere. Remember, Earth got most of its atmospheric oxygen only after living creatures started pumping it out. But oxygen has a faint signal and might be difficult for the James Webb Space Telescope to spot on distant planets. So Mercedes is pinning her hopes for finding oxygen on a new telescope being constructed in an unlikely place. Underneath the football stadium at the University of Arizona, scientists are turning 7 massive slabs of glass into gigantic mirrors.
This is an 8.4 meter in diameter mirror that is today the largest one-piece mirror that humans can build.
When completed, the mirrors, each weighing 20 tons, will travel to a mountain in Chile where they will be assembled into the giant Magellan Telescope, a mega telescope expected to be 10 times stronger than the Hubble Space Telescope. That power will come from the near-perfect shaping and polishing of 7 mirrors joined into one.
We need to polish this mirror very, very finely.
Each mirror takes more than 3 years to polish to within 20 nanometers. That's at least 1,000 times smaller than the width of a human hair.
Every time I see one of these mirrors, I see this big bucket that is collecting light for me. And the bigger the bucket, the more light I can collect, and the easier it will be to detect oxygen in an Earth-like planet. The giant Magellan Telescope is going to be a game changer for us.
The GMT is scheduled to start hunting for oxygen on other planets within the decade.
Technology moves very quickly. I think we will find life on another world. We will find a signature that's a smoking gun for life on a nearby planet.
But could we find more than a smoking gun? While some alien hunters set their hopes on the next generation of telescopes to spot life from afar, some explorers are searching for ET much closer to home. Astrobiologist Kevin Hand is hunting for life in our own solar system, but the aliens he dreams of are very different from the ones in the movies. He's looking for a kind of life that could thrive in some of the harshest places on Earth.
So here we are sitting on a red-hot blister on planet Earth, a volcano.
At Lassen Volcanic National Park in California, temperatures in these springs rise to nearly 200 degrees Fahrenheit, deadly to most forms of life.
This particular bubbling hot spring, of course, does not look like a good place for life. It's not a good place for me, this tree, or any large creature.
And yet, if you look closely, the pools are literally teeming with life. It's just very tiny, microbes.
What's amazing about microbes is that they can survive in a variety of different harsh and extreme conditions. For example, all of the green that you see here, these are microbes that are doing photosynthesis, thriving off of energy from the sun.
But not all microbes need sunlight.
In this stream that's coming from one of the hot springs, we've got microbes that are surviving on all the compounds dissolved in the water. These microbes don't need sunlight.
Kevin thinks he might find creatures like these lurking not too far from Earth.
These are the kinds of life forms that we think could potentially inhabit the deep, dark oceans of other worlds.
But what oceans? None of the other planets in our solar system have liquid water oceans on their surfaces. So, astrobiologists like Kevin are laying their bets on two balls of ice that aren't planets at all, but moons. Enceladus, a moon of Saturn, and Europa, a moon of Jupiter. At first glance, both appear to be barren, but cracks on the surface reveal activity below. Extreme gravitational forces created by their massive parent planets could be causing the moon's rocky cores to heat up. And when you put together heat and ice,
because of frictional heating of the ice against the solid core, you get the formation of subsurface oceans.
Scientists now believe that the ice on both moons covers hidden oceans below, with Europa holding more water than all of Earth's oceans combined. And here, deep in the oceans of these tiny moons, could lie all the fundamental ingredients of life.
If you have ocean water coming into contact with rock at elevated temperatures, you'll get energy for life that's not coming from the sun, but from chemical reactions.
Worlds like Europa and Enceladus, where we've got good evidence for vast global liquid water oceans, could be where a second origin of life occurred.
Kevin thinks there's a strong chance that life could exist on Europa, the larger of the two moons. But how could you ever find it?
You wouldn't want to go to Europa. It would be a beautiful view of Jupiter, but as soon as you stepped out of your spacecraft, you'd die. It's minus 280 degrees Fahrenheit, there's no atmosphere, and then the radiation that would rain down onto you would kill you within a matter of tens of minutes.
Astronauts won't be attempting to skate across Europa's icy surface anytime soon. So NASA is studying ways to send a robotic probe nearly 400 million miles to the bright moon, to hunt for traces of life. But not before we know what to look for. If European sea creatures, even microbes, existed and made their way to the surface of the ice, their cells and anything resembling DNA would be heavily altered by radiation. But Kevin thinks we can hunt for remnants of life in the form of amino acids, the building blocks of proteins.
So if we found amino acids in ice, that could be a pretty strong sign of life within that ocean.
But how likely is it that traces, in the form of amino acids, could survive on the surface and be detected by our spacecraft? To figure that out, Kevin and his team are replicating some of the conditions on the icy moon, right here at NASA's Jet Propulsion Laboratory in Pasadena. In this latest test, Kevin's molecular guinea pig is glycine, the simplest amino acid found in every living thing on Earth.
We're mixing glycine in with water to kind of replicate what could be in Europa's ocean were it to have life.
The mixture goes into a stock pot, a witch's brew of water and salts. Over 3 weeks, Kevin pummels the glycine with the sub-zero temperatures and dangerously low pressure you'd experience on Europa's surface. Finally, it's time to find out if any glycine survived the ordeal.
Okay, well, we've definitely cooked up something interesting in here.
If the amino acid is completely destroyed, the odds of finding some sign of life on Europa's surface are slim to none.
It doesn't look like ice. It looks like a very solid but soft surface. This is almost like a creme brulee, I think. Going in. Ooh, interesting.
I feel like there was a tough crust.
No, it's very powdery. Oh, look at that.
Kevin was expecting a hard, icy shell, but he's surprised to see that the ingredients have frozen into a thick powder.
You can see it's almost like a layered, feathered material.
Now for the real test. Kevin probes the ice with a spectrometer, using light to seek out and measure glycine's unique signature. Can a simple amino acid, a single building block of life, withstand the harsh environment of Europa's surface and be detectable?
Get in nice and close and we'll get the maximum signal.
And like a beacon, it appears. A small but clear signal of glycine. It means that if there is microbial life in the oceans of Europa, we might be able to find some of its building blocks on the moon's icy surface.
Is this what the signal of life on a distant world might look like? We just don't know. Next thing to do is launch a spacecraft and go look for it out there in the solar system.
Finding amino acids on Europa's surface would be encouraging. But what we really want to know is, what might be swimming around in Europa's vast oceans? Could there be microbes, like the ones that dominated Earth's own oceans for billions of years? Or something more complex? If we want to find out, then we need to send a mission much deeper, down through the ice and into the pitch-black oceans below. But how do you prepare for such an ambitious trip to a place unlike anywhere on Earth?
Engineer Bill Stone believes he has the answer.
If you ask me what is exploration, it is the process of putting your boot in a place where no one has ever been before.
Bill's boot is an underwater vehicle named Sunfish, his prototype for an ocean-exploring robot. It might not look like much, but if there's something swimming around on Europa, a miniature version of this robot could be the first to spot it.
It will be one of the greatest intellectual feats of humankind if we pull this off.
NASA is studying how to get to Europa's surface in about 15 years. Bill is planning for a much more ambitious journey. Fly a robotic lander 400 million miles to Europa and land on the surface. Bore through an ice cap some 10 to 15 miles thick. Then release an autonomous underwater vehicle to explore the mysterious ocean below.
Once you get through the ice, Sunfish will go out and map, explore, and look for life.
This wouldn't be the first robotic mission in our solar system. Mars rovers have explored the red planet by following commands that come from Earth, 34 million miles away. That's not possible on Europa, which is roughly 3 times as distant as Mars.
The problem is there's a 2-hour delay light travel time between Europa and Earth. So we can't sit there and joystick something.
This robot must be able to think and explore all on its own, or else it won't be able to see much of the European Ocean. And the mission to Jupiter's moon could be a wasted opportunity.
Where would you like us to position the robot?
To do that, it needs practice.
Okay, here we go, heading east.
We're at Peacock Springs State Park in northern Florida because there is an underwater labyrinth, a maze.
The ground in this part of Florida is riddled with winding, water-filled caves. Can Bill's robot negotiate this confusing environment on his own? A team of experienced cave divers tags along in case the robot breaks down. Other than that, the robot is virtually alone, using sonar to explore and map its surroundings, inch by inch.
The robot doesn't know anything about this cave, and so it is learning to explore as it goes.
So we're at 21.
So 240 points us down the tunnel.
Things seem to be going well until, in one narrow cave, Sunfish stops. It suddenly seems confused.
It's drifting a lot.
It is. Ooh. What do you do if something goes wrong? What's your procedure? All that has to go into the code.
00240D.
A few lines of code outline a new strategy. Back up and remap from a different angle. This time, the robot succeeds.
It's achieved the goal. Turning back.
This is a small step that could one day lead to a giant leap in the search for life beyond Earth.
If there's going to be life on Europa, there is no reason why we can't have life somewhere else in the universe. It'd be the first validation that we aren't the only ones. So from that standpoint, it's going to shake a lot of ground.
If we found evidence of life on Europa, even if it were just a teeny tiny microbe, that would be huge.
All it needs is for one microbe that is life but not as we know it to make the point that it can't be that hard to get going. Just one microbe.
The importance of that is to say, guess what? Biology's not very hard. It's an infection in the universe, right? It's all over the place.
If a galaxy oozing with pond scum doesn't seem too exciting, then remember, over a few billion years, these tiny creatures evolved into all the plants and animals that swim, crawl, and fly around our planet, including us. So could the same thing happen somewhere else? What do we think aliens that evolved on another planet would be like?
Flying saucers have invaded our planet.
In lots of movies, aliens look remarkably like us, with 2 arms and legs.
Only you of Earth, you and your women, can give us life. Get back on fire, you fool.
And of course, those eyes.
From the standpoint of Hollywood, the aliens tend to be these little gray guys with big eyeballs and, no sense of humor, and no clothes, by the way. They seem very dispassionate. They don't seem to get angry. They don't seem to have a lot of fun either.
Come on down, Mr. Ambassador.
Science fiction aliens usually have something else in common with us: intelligence. But what are the chances that life, if it did arise elsewhere, would evolve into creatures with big brains?
After all, aren't we the only smart ones on this planet?
Some biologists would say no.
Good job, buddy.
And they're not just talking about our closest relatives. From dolphins, to birds, to even the octopus, a creature more closely related to snails and clams than to us, but smart enough to use tools and open jars. We're not the only animals who've evolved impressive brains. Of course, none of these creatures will build a spaceship anytime soon. But for many scientists, the idea that we're the only technologically advanced creatures in the universe seems a bit, well, presumptuous.
We used to think the Earth was the center of the universe. That was wrong. Then we thought the sun was the center of the universe, and that was wrong. Then we thought our galaxy was the center of the universe, and that was wrong. Every time we thought we were really special, we were wrong. And so the idea that we're somehow special in terms of being alive or being intelligent, I mean, that's probably wrong too.
I find it extremely hard to believe that in the vastness of our universe, that a rocky planet that harbors intelligent, sentient life happened just once.
Some scientists have spent their entire careers hunting the vast emptiness of space, trying to pick up a signal.
I always just took for granted that there would be other stars that would be suns for other creatures. And that just seemed to me the natural way of the world.
More than 3 decades ago, astronomer Jill Tarter co-founded the SETI Institute, dedicated to the search for extraterrestrial intelligence.
It's been amazing to be able to spend a career on a question that I'm fascinated with, and a question that everybody else out there is curious to know the answer to.
She was the inspiration for the character Dr. Ellie Arroway in Carl Sagan's book Contact, which was adapted to a feature film in 1997. Today, SETI conducts searches with the Magellan Telescope Array, a network of 42 radio telescopes in Hat Creek, California. The telescopes comb the skies for radio waves, which can carry signals and information across the great distances of space.
Radio waves are an excellent way to communicate because they cut through the atmosphere of our Earth and also cut through the space between the stars.
In fact, we've been sending out our own radio waves since the dawn of broadcasting about a century ago.
Morning, honey.
If any aliens are listening, their ideas about Earthlings could be based on the Dick Van Dyke Show.
I said, how's my old lady?
Well, I don't know. I haven't spoken to your mother lately, but I'm fine.
The hope of SETI is that some aliens might also be broadcasting.
The idea is that if life is sprung up on some other worlds and it's technological life, in other words, they've learned a little bit of physics, they build some equipment, this, that, and the other, they could build radio transmitters that are sending signals into space that we could pick up here.
At Hat Creek, the telescopes listen in on millions of radio channels at a time, looking for unique patterns that could be alien transmissions.
When something shows up that we don't think is interference, something that we've not seen before, immediately we follow up on that signal to try and figure out what it is and whether it's, in fact, our technology or potentially someone else's.
But unique signals are rare, just 1 or 2 a year. And so far, even the most promising ones have turned out to be human interference. Still, the event that SETI is waiting for could happen any day.
Okay, point source confirmed. Whatever it is, it ain't local.
While Hollywood has fantasized about this moment of discovery, it's harder than it looks. The Magellan Telescope Array can only listen to a few 100 million, out of billions of possible radio frequencies at a time.
We haven't yet figured out how to look at all the sky, all the time, at all frequencies, but that's ultimately what we want to do.
In fact, we've been listening for nearly 60 years, and so far, crickets. But the fraction of stars we've searched carefully and the amount of time we've been listening are still both quite small. So plenty of people remain hopeful that technologically advanced civilizations are out there.
And that's why the mysterious dimming of one particular star was, for some, so tantalizing.
In 2015, astronomer Tabithas Star and her colleagues published their findings about a very weird star. According to data from the Kepler Space Telescope, Tabbys Star was dimming at strange, irregular intervals, sparking theories about an enormous structure built by a hypothetical advanced alien civilization. The buzz spurred more research. Today, a worldwide network of powerful ground-based telescopes stare at Tabbys Star round the clock.
We can actually process the data in near real time, and when we see something start to happen, we can trigger more intense observations of what is passing in front of the star at that time.
For a while, the star was silent. Then suddenly, it started dimming erratically again. The ground-based telescopes provide information about the star that Kepler couldn't see. Not just the dimming of the star, but how those dips in brightness appear in different colored wavelengths.
Something is happening with our star here. We sent off alerts via Twitter, and data of all sorts started coming our way. At this point, it's like we're swimming in data.
Tabby and her team at Louisiana State are looking for patterns in the color data that could tell them what kind of material is passing in front of the star.
Blue light and red light will react differently to material that's passing in front of the star. You'll have a different signature in how far down these dips go.
Whatever is passing in front of Tabbys Star appears to be blocking more blue light than red and orange light. But what would block out more blue light? Tabby has a theory: space dust.
Dust scatters blue light more than it does red light. And so that indicates that there's some sort of dusty, semi-opaque, material that's crossing in front of the star and blocking out the light.
It's got the signatures of being dust rather than it can't be some kind of completely opaque object, like a planet or an alien megastructure.
That's right.
The culprit is likely scattered dust and not a solid alien megastructure. But the mystery is hardly solved. What created this giant cloud of dust? Why is it centered around Tabbys Star? Astronomers will need more data if they're ever going to crack this one.
Nature is a lot more creative than we are, and we're just gonna have to really buckle down and try and figure this one out.
Tabbys Star is one in a long line of mysteries that, at first, raised hopes for finding ET, but later were revealed to have solutions unrelated to life. For some, the lack of firm evidence is troubling.
In 1950, physicist Enrico Fermi went to lunch with some colleagues and asked a simple question: where is everybody?
If there are billions of habitable planets out there, and life is common,
why haven't a bunch of aliens already shown up on our doorstep? What could explain the silence?
For some, the quietness of the cosmos is evidence that we really could be alone. But many astronomers disagree.
The idea that there's intelligent life out there that has never interacted with us or that we've never seen it, that to me is not confusing at all. I mean, I think that's perfectly consistent. It's no different than a child looking at an ant farm. The child is not going to be compelled to interact with an individual ant. And more so, the ants probably don't even know that the child is analyzing the ant farm. And so there's very likely intelligent civilizations out there that may be looking at us, but what do they have to gain from interacting with us? We might be very basic and insignificant compared to them.
Or perhaps interstellar travel is too challenging, even for super smart aliens. Or maybe they did exist, but ended up destroying themselves. For many, the universe is simply too large, too many stars, with too many planets, too many potential homes for creatures that might start small, but could, like us, thrive and grow.
The universe is mind-boggling. It's bigger than what we humans can actually wrap our consciousness around.
The universe has hundreds of billions of planets in hundreds of billions of galaxies.
So it just seems like when you roll the dice many, many times, that one of them is going to luck out.
We live in a groundbreaking era. We might be the first generation that will be able to say that there's life elsewhere in the universe.
Our young people have a much greater opportunity to see themselves as Earthlings.
But we also could find out that, to the best of our ability to measure, we really are alone.
If it turns out that Earth is rare, then that's all the more reason to look after what we've got. Because if we destroy ourselves, the flame of mind and the flame of culture will be snuffed out for good.
I hope that we aren't the only things out there. There's got to be something else.
You know, there's a lot of room up there. It's hard to believe that everything interesting is down here. It just never struck me as a very reasonable point of view.
Are we alone in the universe? Not a chance.